So this is one of my favorite videos and favorite tutorials, to be honest. It's how to structure a search endpoint. With a search endpoint, you're going to be dealing with a lot of different variables, how to add filters to your query, how to limit your query, how to paginate your query. And when you get into those really large queries of your database, through Eloquent especially, you can end up with code that's 20, 30 lines long just to perform a single query. What I like to do is I like to structure our search endpoints in a modular fashion. So every time that you add a feature to a resource, like, for example, our cafes, say if we added hours or if we added products, you can take those resources and add them to the query in a modular fashion. So when you're structuring your GET request, the GET is the HTTP verb. When you're structuring that request to query the database, it's really fluid, really modular, and easy to expand on, and also easy to find errors. Let's get started. The first step of this process is to open up your api.php routes file. I always start any new feature, any new implementation on the API side before I jump over to the single page app side. I believe it builds a nice foundation. It goes and has all of your business logic and functionality ready to go before you try to design a UI. So what we're doing in this tutorial is going to design a cafe's search endpoint. Now, with a search endpoint, we're going to be submitting a GET request. A GET request is built off of the URL parameters, and that's how you filter and query. The GET request, there's been talk of the future of making a search HTTP verb, which I would be completely down with, but for now we have to work with what's available to us. So in our api.php file, this is our routes file, you're going to find an endpoint called just get, and it's going to be cafes. And it's going to resolve to the cafes controller and search method. That's all we need to do to register our search endpoint. In the next step, I'll show you how to build out the controller method that handles this endpoint. So now that we have our endpoint, we have to have the controller method that resolves the method defined in our endpoint that handles that method. So for us, we did that in the cafes controller, and you can see it'd be app HTTP controllers, and we made an API namespace and threw a cafes controller in there. So right off the bat, this looks like a normal resource controller. And normal resources controllers don't have a search endpoint. They usually have an index endpoint, a show endpoint, those methods that are standard for RESTful resources. And you could argue that you could use the index and allow features to, or allow filters to be added, because the index returns all of the cafes. But in our sake, the way that we structured this is the index filter returns all cafes for a company. Our main purpose of this structure is we have companies as a high level and cafes as children underneath a company. But in some cases, you want to find cafes. You're not going to find a company that does pour over coffee. You need to find a cafe that does that. So we added a search endpoint to our cafes controller. And I believe that's the best approach to having that search functionality. If you open the cafes controller, and if you have access to our GitLab, you can see this. The cafes controller has a search method, and it takes a search cafe request. So the search cafe request applies a little bit of validation to what you're passing in for to make sure that your search parameters are set up correctly. We also have a search cafes service. So I'm a big fan of keeping controllers as small as possible. They should be kind of like the gatekeepers to your business logic. So for pretty much any of these endpoints in here, we have a service that handles 100% of the functionality. So our search cafes endpoint is no different. We have a search cafe service. We pass the service all of the request parameters, so that'd be all the filters, all of what we're searching for, all of our limitations, any sort of additions that we want, like do we want the amenities that are involved in the cafe, and we run a search method on that controller or on that service. The result of that method is we get a bunch of cafes and we can return them as JSON. Now, this isn't too powerful, but in the next step, when we build out our search cafes service, you'll see how we structure this endpoint and how you can see how it's reusable, scalable, filterable, all the good stuff, and really easy to add to. See you in the next step. So once we have our search method in our cafes controller, we create a service. And in that service, if you have access to our GitLab code, you can see how we structured it, and you can open it up and follow along yourself, or I'll guide you through the process. So the search service is under App, Services, Cafes, Search Cafes. Now at initial glance, there's a lot going on in this file. But once we break it down, it really makes sense on how we structured it this way because it's scalable, reusable, and allows you to add features to your search service that, if you add something new, it's not a headache to return those results. You could do all of this stuff within like a single Eloquent query, and it'd probably be 30 lines of code, but also be really hard to maintain. It would look really weird, and it wouldn't be as modular and as functional. So let's break this down a little bit. The first part of our service that we really want to dive into is the construct method. This allows us to send a bunch of parameters to our search service and use those parameters to build a query. If you take a look back at the cafes controller, where we implemented or where we use the search service, we pass all of the request parameters that the user has sent to our endpoint. So in there, we can filter by brew methods, we can show amenities, we can filter by company, we can do a lot of different stuff. It can be very variable, they can want a lot of data, they can want a little bit of data. No matter what, we pass all of the possible request variables to our Search Cafe service. So the first thing that we do is these parameters, the request variables, is we sync them locally. If you look up at our search cafes, we have a ton of private variables. These are all of our features that you can limit, order, include, filter, anything that we can accept from this endpoint. So what we do is, or what I like to do is go down to set local parameters and pass in all those request variables. If we go down the bottom of our service, we have this method called set local parameters. And what this does is it checks to see if one of the possible parameters is set, and if it is, we use it. Otherwise, we set a default value. Say if the take parameter, so take would be, I want X amount of cafes. I want 20 cafes returned. If we set that, we can return 20 cafes. But if we don't set it, we default it to 6. Same with ordering by. If we want to order by the cafe's name, well, then we can pass in the order by of name. Otherwise, we order by newest, and we order it newest first. And we do that for all the possible parameters. So we always have a default. We can always use the same methods, but we can override them through our URL variable or through our request variables that come from the URL. So I find that setting the local parameters right on construct is one of the fastest ways to ensure that you have proper data, that you have a default set for any parameters, so you don't have any unknowns or something that's out of the ordinary, and it really makes it clean on where you set everything up. So we just pass it off to another method. The other thing that we do in the construct method is we initialize the cafe query. Now this is an Eloquent query, and this is a method that makes this whole functionality possible. So we have a private query variable right here, and we have it set to cafe in the query method. All this does is initialize a query that will be using the cafe model, and from there we can expand upon that. In the next steps, we're going to break down a few of these methods, and you can see how it's modular and scalable from there. So the guts of this whole service is the search method. We went through the construct method in the last step. The search method is where we can apply all of the different search parameters and filters that we need to make this functionality work. And really, we might not use any of these. We can maybe we just search cafes and that's all that we need. But as we go through it, you'll see how we structure that. No matter what, the method will get called, but it'll be configured based on what the user is looking for. So let's start with the first one, apply search. Say a user wants to filter Ruby coffee out of Nelsonville, Wisconsin, and they pass in, they know it's Ruby, they don't know much about it, they search Ruby. So when we apply search, we come down to the apply search method. Did they enter anything to search? Well, if they did enter something, then we can filter it. If they don't want to search by a name or by a string, we don't even use this method. It just goes to the next one. But how this works and the key to making it work is, remember in our construct variable we have a this query equals cafe query. That's the key, because from here we can add to that query. So if the search is set, then we URL decode the search, make sure that we have proper readable text that we can search. There's no %20s for spaces from the URL. And then we apply it to the query. So we apply a query where any of these columns on the database match what the user is searching. Location name, which would be Ruby. Address, well, that probably won't be anything unless there's a street named Ruby. City, state, or the company name is Ruby, which would probably match. But that only runs if the user applies a search variable. So that's how each of these methods is structured. Let's look at another one real quick. Similar to the search method, we have a couple other where we apply a where statement, like the apply company filter. If we know the ID of the company and we pass that through the get parameter, we can apply and filter based on the company ID. Say that we know that company 3 is Collectivo Coffee out of Milwaukee, and we want to find all their cafes. I think they have like 15 cafes. We can pass in company 3 and filter all cafes by company 3. We can keep narrowing it down from there, like company 3, location, lakefront. And then it'll only return a single cafe that matches those parameters. So those are examples of where functions, and the where can be used to limit your search results. And most of the methods that we have within our search service are applying where to limit results. Now, it does follow, if you look at the search method, which is like the guts of our search service, it does follow a certain order. We apply our where filters first, because those are the ones that, if you're building this as one giant Eloquent query or any other query, you'd have to filter it first before you apply anything else. But if we look at the apply liked, you can see it has a where has. Now, this is similar to where, but it's where the user has or where there's a like for the user. That's a little bit outside the scope of this tutorial, but it's also in the proper flow of, or at least the flow I like to do it, of we do the where, then we do a little more complex for where has, and at the very end we apply other things like applying the order, or we apply where it filters or orders the results by whatever the user wants, whether it's the most liked cafes first or whatever column they pass in with their direction. So the big takeaway from all of this, if you want to sum it up, apply your where filters first, apply some of the more complex where filters such as where has, then apply the order. So you're building your query in small little chunks. So if you need to add anything, say if we add products, we can even go beyond this. So we do our where, and then we do our with. So with products, or with hours, or whatever other features that you want to add to your search results. Just remember to follow an order that makes logical sense when constructing a query. After we have our query constructed, then we can actually run it. So how do we get the results? We have cafes, and that is this query. So this is our local query that we've been building the whole time, and we want to return the company along with the cafe. That'll give us a nice, beautiful result. We'll have the company logo, the company name. Because if you just return the name of the cafe, it doesn't really make a lot of sense. It might just be an address, or it might be something like, in Collectivo is just Lakefront. Well, Lakefront doesn't define what company owns that cafe. The only thing that we do in this to make the results a little bit easier to work with is we add a paginate. So paginate is built into Eloquent in Laravel to paginate your search results. It's insanely powerful. As Roast grows, I think we're up to like a couple hundred cafes, about 100 companies. There's a lot of data. So we don't want to return all of that at once. We want to return whatever the user wants or whatever our app defaults to. Like on the home page, it defaults to 6 right off the bat. But if you want a search results page, we default it to a few more, like 10. If you're consuming an API from a third party, you could ask for 20 in a single request. The take parameter is what limits how many results are returned every time you make a request. And paginate returns a beautiful object that has our results, that has a next page, how many results there are, so you can work that into your UI and make it really nice for the user to browse. But what we do is we finish our query by calling paginate, which returns all that data, and then we return cafes. So at the end of the day, we have our search method, we apply our filters, we apply our order, we get our results, and then we return our cafes. If we step back to the cafes controller, we take those results, return them as JSON, and send them back to the UI. So that's how I beautifully structure a search endpoint using Laravel. In the next step, I'll show you how to consume the results, and that's on the single page application side. So right now I have the Roast front end open, and the index.view file, this is our home page. So if you're familiar with Roast, this file right here is this page, home page. Now in the home page, you can see that we have newest cafes. This is a perfect example of using our search method, or our search endpoint, to return cafes. Within Roast, the parent is companies and the child is cafes. So that's why we usually have, resource controller has an index, but we call the index method when we're on the companies page. So an individual company will call the index of the cafes on that company because it's a sub-resource. But on the home page, cafes are treated as their own primary resource. And the search method we implemented is a great way to filter that resource and to allow the user to really narrow down what they're looking for. So let's jump back over here to the code. We have a async await method, so asynchronous method to load the cafes, and this is called on multiple areas. The most primary area that it's called is when the page is mounted. So we want to load the initial amount of cafes. The secondary place that it's called is when we paginate through the cafes. We can pass all the filters that we have to our search endpoint and get the results with paginated. So if we're on page 2, we get the second X amount of cafes. We're on page 3, another chunk. And in our case, that's 6. So the initial page 1, we're going to take 6, order by the created at and order by the direction descending. So get the newest cafes, take the first 6 of them, display them on the page. Now the next page, we take the next 6. And that allows us to paginate through all of our cafes really easily. If we wanted to narrow it down, maybe consume this from a third party, we could add filters on names, locations, states, etc. The only other thing I want to point out is this page parameter. So when we're calling the search endpoint, we're just passing all of our filters, all of our information right to that endpoint. The page parameter comes into play when you're paginating your results. Laravel looks for that request on pagination for which page it's on, and that's essentially the offset. So if we have, we're on page 10 and we're taking 6, we start at the 60th cafe and go to the 66th cafe. That's how the pagination system works within Laravel. But the power of the search endpoint is we can hit it from multiple areas, filter as much as we want, and get data returned in the same format and allow us to expand and add new features while easily maintaining that endpoint. It's a lot to go through, but I think it's super powerful and you can easily implement it into your applications. I know that pretty much anything that I built, we implement these type of search endpoints and these structures of our Eloquent queries. And right off the bat, it seems like a lot, but as we move forward and as we begin adding features, it's so much easier to maintain. If you have any questions about adding search endpoints, hop on over to our community. We have a special section for those who have bought the ultimate package of the book, and you can ask any questions that you want, and we'd be happy to help.